Hello and welcome to Lucian Academy Walkthrough. Today we take a deep dive from philosophy to algorithms to the frontiers of artificial minds, exploring Lucian's pedagogy, his core philosophical ideas, and especially his work on manual neuronets, how they work, why they're ambitious, and what they inspire to do for humanity. This will be a long walkthrough, so feel free to pause or skip ahead to topics of interest. I'll mention timestamps in the video description. Let's begin with background and foundations, Lucian's life, pedagogy, and philosophical worldview, then move towards the computational side, culminating in his manual neuronets and their design principles. Lucian Green is the author of Lucian's Pedagogy from 2012 and has written on meditation, computational philosophy, pedagogy, and things like that. He also operated the Lucianpedia wiki, the Lucian Academy website, and several GitHub repositories tied to his computational and philosophical projects. His blog, Lucian's Pedagogy, beginning 2008 onward, lays out methods combining meditation, reasoning, and structured learning to aim for high academic distinction. In his academic engagements, he delivered talks about Heidegger and Taoism, computational hermeneutics, metaphysics, and things like that. Lucian presents himself not only as a thinker but also as a pedagogical engineer, someone trying to build systems, mental, algorithmic, social, so that students, thinkers, or even robots can learn, reason, and grow more perfectly. One way to see his project is that he is blending meditation, philosophy, and computation into a unified framework. The pedagogy is not only about getting good grades, but about aligning one's mind, reasoning, and even machine intelligence with a higher order of knowledge. Over time, his interests have extended to computation tools, GitHub, CI/CD, state-saving interpreters, Spectre algorithm projects, and even time machine immortality speculation.
What is humanist pedagogy? Lucian's humanist pedagogy is his name for an algorithmic, structured method of achieving excellence, particularly in school and university settings. At NN, let's unpack some of its building blocks. Key concepts in the pedagogy. 1. Details objects and uses types. 1 pedagogical exercise. For any object, think of 2 uses, a future use, and 2 types. These details are meant to deepen conceptual richness. At NN. 2. Reasonings, reasonings, breathsonings. These are Lucian's invented terms. Reasonings, calculations of an object's x, y, and z dimensions to write clearer sentences. At NN. Reasonings, computations over how a subject touches an object, e.g., relational aspects. Breathsonings, human judgment computations over a noun, like sentiment or quality. Rebreathsonings, same, but for verbs, computing human judgment over actions. 3. Room, part of room, direction, time to prepare, time to do, time to finish. In Lucian's pedagogy rules, every action is located spatially, room, directionally, and temporally, computing time to prepare, do, and finish. At NN, these tasks are meant to train one to mentally model tasks precisely. 4. Professor algorithm, refining one's reasonings aims to reach high distinction, high D, etc., iterating and optimizing judgments. At NN, through these, the student constructs a rule-based cognitive system, define domains, objects, actions, rules, exceptions, and signposts, tokens that route logic to specific rules. Lucian's pedagogy aims to couch reasoning in formalizable algorithmic structure, so learners can explicitly see contradictions, rule priorities, and how to resolve them. Pedagogical style and philosophy. The pedagogy is algorithmic and explicit. Instead of relying solely on intuition or essayistic feel, the student is meant to build a system of rules and reasoning. It is integrated with meditation mental work. Lucian sees a connection between inner alignment, via meditation, and the rigor of logical systems. It aspires to automate and externalize reasoning. Parts of one's mind, ethical systems, or pedagogical rules may be externalized, written, coded, versioned. There is also a spiritual, or ideal dimension. The pedagogy is not just for grades, but for higher knowledge, purity of mind, and being aligned with metaphysical truths. His pedagogy is where philosophy meets software engineering for the mind. Philosophical and computational foundations. Let's proceed to the deeper philosophical computational core underpinning Lucian's thinking. This knowledge is crucial to understanding how he justifies his manual Neuronets design. Computational philosophy, hermeneutics, and SPECT algorithm. 1. Computational hermeneutics, interpretation of texts. Lucian refers to computational hermeneutics of texts, treating interpretive work as algorithmic parse, map, reason, model ambiguity. N. He also uses the notion of computational English, analyzing English text by algorithms, as a substrate for reasoning. N. 2. GitL, Lucian CI/CD, state-saving interpreter. His GitHub projects reflect his vision of building software scaffolding to support his mind educational architecture. N. GitL, a decentralized Git server, version control. Lucian CI/CD, automated testing integration. State-saving interpreter, an interpreter that can save and restore variable plus recursive state to disk. Other projects: SPECT algorithm, time machine with immortality, languages prologue list prologue interpreter, etc. N. The idea, the mental systems one builds, reasoning, rules, grammars, should be versionable, testable, and reversible, as in software development. 3. SPECT algorithm, grammar, and rules. Lucian often refers to SPECT algorithm methods. You start from specifications, then derive algorithmic, simplified forms. This resonates with his manual Neuronets ideas. See his SPECT algorithm playlist on Lucianpedia. N. Grammar generation is also central. He aims to create CFG-like grammar rules that can underlie algorithmic structures, and from which you can generate or transform programs without invoking function calls at runtime. 4. Philosophy of rules, domains, signposts. In his scheme, you define domains, contexts, or types. Rules, predicates, are sentences, and signposts, tokens that route to rules. Over time, as data, student feedback, texts, examples accrues, the learner or system updates the rule sets and priorities, merges, resolves contradictions, and version controls them. 5. Rule evolution over time. The system is dynamic. As new examples or texts come in, the learner must adjust rule priorities, discover exceptions, refine synonyms, and update the structure of the rule system. 6. Relation to classical philosophy. Lucian draws analogies to Platonic forms. He sometimes equates a reasoning with a Platonic form, uses Plato's forms to structure his 16,250 reasoning zones, etc. N. He claims that computational English plus pedagogy plus metaphysics can realize a modern forms in action system for meaning and reasoning. Research update June to October 2024 and ambitions. Before diving into the Neuronets, let's note what Lucian claims have been recent developments as of the mid-2024 period. Research June to October 2024. From the Lucianpedia page, research from June to October 2024. Lucian reports significant advances in algorithmic research, educational frameworks, and integration of mind-reading technologies into computational systems. N. His work pushes traditional computing boundaries, aiming to merge technical expertise with philosophical inquiry, aligning education, computation, and mental states. N. One focus seems to be bridging mental intention internal states with external algorithmic structures, i.e. taking what usually is private intent, thought, and making it legible or actionable in algorithmic form. So the research direction is not just better algorithms, but algorithms that can understand or mirror internal mental states, and link them to pedagogy and reasoning. That's where the manual Neuronets come in as a locus for mind-machine integration. Manual Neuronets, vision, and design. We now outline Lucian's concept of manual Neuronets, what they are, how they work, per his publications, and how they aim to change the world. What is a manual neuronet? By manual neuronets, Lucian means an artificial neural network, or hybrid network, that is constructed, maintained, and evolved by hand rather than wholly by gradient descent or black box learning. The idea is that a human or system designs the network structure, rules, and transformations in an explicit, interpretable way so it can evolve, be audited, and align. A manual neuronet is not just a neural net in the classic deep learning sense, it is a network built with rule nodes, explicit transformations, logic, grammars, and possibly learnable weights, but always under a human-guided structure. The ambition is to build artificial minds that are transparent, controllable, aligned, and philosophically grounded, not black box AI. These neuronets can then be used in education, reasoning, mind reading, or augmenting human cognition. Let's look at the specific principles Lucian gives. Core principles and algorithms, manual neuronet plan. Lucian describes several algorithmic modules design principles. I'll translate them into standard computer science language, and then map them to his descriptions. 1. Complexity analysis. Quantify code complexity for optimization. For each module, evaluate computational cost, time, memory, and prune or restructure accordingly. 2. Type inference. Automatically or semi-automatically infer argument types for nodes functions, so that rules are well typed and errors are detected early. 3. Pattern unfolding. Algorithm unfolding. Simplify algorithm structure algebraically, eliminating inefficiencies, flattening recursion, inlining or merging rules when possible. Data unfolding. When possible, simplify data structures or constants, memoization, constant folding, so the algorithm collapses redundant parts. The goal is to remove optimization problems by design. 4. Grammar CFG generation. Build context-free grammar, like rules, without function calls, that serve as the backbone of reasoning, from which code or transformations can be derived. The grammars and values exist independently from executable code, to allow symbolic manipulation, proofs, or hand simplification. 5. Rule finding and optimization, bidirectional. Work from the input side, parsing data, examples, and the output side, desired results, to deduce minimal, highest priority rules. Simplify rule sets dynamically. Use synonyms, exception rules, signposts, etc. Also, use ranking and versioning of rules, which to priorities, over time. 6. Domains, rules, and signposts. Domains. Assignments are contexts, types categories. Rules, predicates, are declarative sentences. Signposts, tokens, or pointers that tell the net which rule to use next, like dispatch. The network works by mapping data through domains, then routing through signposts and rules. 7. Learning and evolution. The rule set evolves as new data, texts, feedback, queries arrives. Contradictions are resolved, rule priorities are updated, exceptions are added, synonyms are recognized, and version control is applied. The learner, or human overseer, curates the evolving net. 8. Integration with pedagogical data. The neuronets are fed with student feedback, textual inputs, meditation outputs, internal states, etc. The net must integrate phenomenal subjective data, intention, focus, with objective rule-based input. How the manual neuronets work. Sample flow. Slide animation. Data domain routing grammar rule application output feedback. Walk through a hypothetical example. 1. Input, a student writes an essay sentence. 2. The net routes it via type inference, and domain assignment, e.g., English sentence domain, argument domain. 3. A signpost token routes it to candidate rule sets, reasoning, rib-reasoning, grammar, style rules. 4. The net pattern unfolds the structure, splits subclauses, simplifies nested structures, and prunes redundant parts. 5. The net applies grammar CFG transformations to rewrite or optimize sentences, e.g., merging subordinate clauses, eliminating repetition. 6. The output is a revised sentence plus an explanation trace, which rules fired, priorities, exceptions. 7. The student can review the trace, accept modifications, or adjust rule priorities. 8. Feedback, which modifies the student's errors, is logged and fed back into rule evolution. From the computational perspective, the net includes nodes representing rules, transformations, grammar productions, weights or priorities for selecting among rules or exceptions, storage of synonyms, exceptions, and version history, modules for complexity analysis, pattern unfolding, and type checking, interfaces for human oversight, rule editing. Because the net is manual interpretable, every decision can be traced, and new rules can be added, merged, or pruned without black box retraining. Why this approach? Transparency and alignment. No opaque neural weights you cannot inspect. Interpretable learning. Rule updates can be audited, reasoned, and ethically constrained. Hybrid flexibility. You can embed learnable parameters for scoring within a rule-based scaffold. Integration with pedagogy. The same rule grammar architecture that guides human learners guides the artificial mind. Evolution over time. The system improves via curated feedback, not blind gradient descent. World-changing aspirations and impact 85 to 100 minutes. Now let's discuss why Lucian is doing this, what his vision is, and how manual neuronets might shift the world. Aspirations and applications. 1. Educational transformation. The neuronets could act as tutors or co-reasoners, helping students think, reason, and improve via transparent feedback. Because they use the same pedagogical framework, reasonings, grammar, rule evolution, the human and artificial minds share a cognitive language. Students can inspect how the net reasons, align their minds to it, and gradually internalize the reasoning style. 2. Mind reading intent inference. Lucian's recent research suggests integrating mind reading technologies, connecting internal mental states to algorithmic representation. At NN, a manual neuronet could monitor internal signals, meditation outputs, or intention traces, converting them into rule-level representations to guide system behavior. 3. Ethical aligned AI. Because the nets are transparent and governed by human-curated rules, they offer an alternative to black box AI systems, reducing the risk of misalignment, unintended behaviors, or AI weirdness. 4. Augmented human cognition symbiosis. The neuronet could become a cognitive tool, a partner, assistant, or extension of a person's mind. Because reasoning is explainable, humans can trust, debug, and evolve it. 5. Philosophical metaphysical ambitions. Lucian's deeper metaphysical project is to merge mind, computation, and metaphysical truth. The Pedagogy Plus Neuronet architecture is a bridge between spirit and machine. The net might be part of his speculations on immortality, time travel, or enhanced consciousness, via his time machine and daily regimen scripts. 6. Societal transformation. If these neuronets scale and align, education, governance, AI assistance, and human-machine symbiosis could shift, elevating how people think and collaborate. In short, Lucian proposes that the next frontier isn't just smarter AI, it's transparent, structured, philosophical AI, intimately tied to human minds and reasoning systems. Conclusion and future directions. Let's wrap up. We started with Lucian's life, pedagogy, and philosophical foundation. We then explored his computational ambitions, rule-based reasoning, grammar generation, evolving rule sets. We dived into the manual neuronet concept, which explains how Lucian intends to build AI that is transparent, structured, and aligned with human thinking. Finally, we considered his grander vision, education, alignment, cognition, and even mind-machine symbiosis. Possible next directions. Hybrid models combining manual neuronets and machine learning, e.g., using learning for scoring, but structured rule scaffolds. Meta-learning, neuronets that evolve their own rule creation heuristics. Scaling to sensory domains, vision, audio, or continuous spaces. Empirical tests, pilot tutoring systems, measuring student improvement, and feedback loops. Philosophical work, refining how internal mental states map to rule structures, or how metaphysics and computation integrate. If you'd like, I can help you generate slides, animations, or even example code, toy manual neuronet, based on Lucian's style. Do you want me to build that next? Thank you for watching. See you next time on Lucian Academy.